Okay, so if we want to use earthquake waves to locate earthquakes, how are we going to do that? The way we're going to do that is by recognizing that we have P waves that travel faster than S waves. So we're going to have a difference in arrival times. P wave is going to arrive first, S wave is going to arrive second. If we do that, see that, and we recognize that the material that the waves are moving through makes these waves move at a constant speed, we're able to take the difference in arrival times and come up with a distance that these two waves have traveled from a single source. Does that make sense to you guys?
Mm-hmm.
All right, so since we have a distance from a single source, how many of those are we going to need to be able to pinpoint the location of the single source? 3 is correct. This is called triangulation. So, what we end up having is we have 3 seismic stations, A, B, and C. We're going to go through the exact process in a later video, but to give you guys an introduction, we know from our seismogram and our difference in arrival times that the distance from A is, let's say, 400 miles. That means that 400 miles, any point 400 miles away from A, represents a possible location for this earthquake. So if we draw a circle with a diameter of 400 miles, we know that somewhere on that circle lies the location of our earthquake. If we do the same thing with location B and find that it is 700 miles away, we can draw another circle and know that somewhere on that circle, pretty bad circle, somewhere on that circle is the location of our earthquake. But now we've narrowed it down to 2 possible locations because we have these intersecting circles. So it can either be here or here. Same thing we do with C and find that it is 1,200 miles away. Draw another circle. Anywhere on that circle could be our earthquake, but now that we have 3 circles all intersecting in one spot, we now know that this is the location of our earthquake. So this is the process we're going to go through. You guys have in your, you guys have the exercise that has all of the seismograms, and you have a chart that we're going to use to find the distance from your earthquake based on these different arrival times. So move through the next couple of slides to get instructions on how to do that.